While they're getting ready, David Loughery from All Planners, our next speaker. After completing an engineering education and practicing for several years abroad, David came to the U.S. and has been involved in an AEC software industry ever since. Spent most of his career working in software, aiming to make BIM for infrastructure a reality and implement it industry-wide. So without further ado, I'll get out of your way and let you roll again.
No, absolutely. So thanks everyone for having me. I'm going to go a little bit off script compared to what I originally intended to say, because I think Stanley's covered a lot of the challenges of implementation pretty thoroughly. I'll address them a little bit later on, but I'm going to start off more with a discussion of why we do this in the first place. I'd like to start off with project challenges, and not the project challenges of delivering in BIM, but rather the project challenges of trying to deliver in a conventional CAD environment. I think everyone here probably is aware of most of the challenges they face day in and day out. Going to look at a framework for kind of understanding them. A few examples, well, one example specifically in the interest of time, look at BIM itself and how it ties into culture and how these things can impact those challenges that we face currently, and then case studies thereof, and then finally look very briefly at implementation. By way of defining the problem, I mean, there are 5, 6, probably more analytical frameworks for understanding why projects go off the rails, for understanding why there are challenges. My personal favorite is one from a Danish economist whose name I can't for the life of me pronounce, that was originally oriented towards mega projects, but I think kind of encompasses a lot of the difficulties that we face. Everything from really the planning horizons involved to this, what we call uniqueness bias, that we think every project is a one-off. There aren't necessarily mass manufacturing applications, so we don't think that there's much to be learned from elsewhere, through to the fact that in conventional CAD environments, we don't get a ton of interdisciplinary coordination, and what we do is challenging to achieve. Lastly, kind of a optimism bias when it comes to cost estimation, and the fact that we don't always have good data to feed into cost estimation early on. I'm going to use everyone's favorite punching bag to kind of outline where these come in, so I apologize if anyone in the room was involved in this project, but it is, I think, the traditional example of when almost everything goes wrong. Everything from the fact that there were dozens of people and dozens of entities, rather, involved in the planning, and that, for instance, there were several $1 billion spent on mitigations that weren't envisioned and may not have been needed. Everything from soundproofing for buildings that were across town that people had applied for grants for, to rat control when they apparently managed to kick out the entire population of rats that lived under Boston and they all fled into residential buildings. Obviously, mega projects in particular are uniquely vulnerable to these, but I think everyone's been involved in a small-scale project that has had problems like this as well. Black swan events like massive early snowfall was something that happened to me once. Failure to account for complexity. Geotechnical is everyone's preferred example here because it is so hard to come up with good geotechnical data. But then what does BIM do for these problems? Well, step one in answering that is answering the question, what is BIM? And this is where I'm cribbing from a quote that Chuck, I think, in January at TRB actually made. The question of what is BIM is not to say, all right, building information modeling. I think we all understand that, but what is BIM as a process? What is BIM as almost a culture? Or what is BIM from the standpoint of actually getting it right, not just what does it mean? The idea that it is agreed upon processes and agreed upon tools, whether it's proprietary software, whether it's the IFC format for exchanging information between different softwares, that leads us to an information-dense model. And then what are we doing with it? Well, it's a basis for communication, for collaboration, for simulation and optimization. At its most ideal, we should be able to do everything with this model. We should be able to do visualization. We should be able to do both conceptual design and cost and preliminary costing for multiple conceptual designs, through to FEM and detailed design, straight through to project delivery and plans production, and then through to detailing. And then finally, an asset management tool with an as-built model. Tying this in really to the 2D side of things, what challenges are there with 2D deliverables? Speaking from my limited experience as a project engineer, and I hope if anyone has any comments, please chime in. When it comes to creating projects, especially when it comes to creating documentation for projects, we require a specialized workforce and a lot of repetition. The embedded information in a CAD environment is quite limited, and it's not necessarily well organized. In a very real sense, we spend a huge amount of effort from a huge number of people putting a lot of information into a digital platform, and then the only way to extract information from that platform is with Mark I eyeball. It doesn't necessarily make sense. When it comes to internal consistency, this is always a problem. How much of everyone's QA/QC process is focused on flipping back and forth across 150 sheets and making sure that every time a detail is featured, it's the right detail, it's the same detail. It's both fragmented and at the end of the day, it's very redundant, the amount of work that's done. Finally, ease of understanding. This is why we have drafting standards today. This is something that BIM is oriented towards fixing, both from the standpoint of clarity as well as accessibility. We have drafting standards specifically so that all the plan sheets represent the same item in the same way, the same object in the same way, and everyone knows what they mean. So how do these tie back into the reasons that projects fail or the reasons that they become expensive in the first place? Well, I would say, for instance, that the shortcomings in creating a project lead us to think that our projects are unique. It takes so much time and so much effort to find old similar projects and then to understand what was done there that in many instances it's not even worth doing, or at least we don't perceive it as worth doing. So unless you have personal or institutional experience with a similar project, I've very frequently seen that people tend to just think, all right, well, let's develop a solution from scratch. It's almost like reinventing the wheel. Another example would simply be that the quantity and quality of the information that we get really does limit our ability to estimate costs accurately early on. We come into problems like the California high-speed rail project, where no one really had a good understanding of what it was going to cost. And because of that, it was very nearly impossible to plan for it. So what then does this have to do with culture? Its most basic, work culture comes from people. More specifically, though, it comes from habits. It comes from the way that we work, the way that our firm approaches certain tasks, the way that we're trained to do things for our companies. But these habits then, I would say, come from tools. You work the way you do because it's what your tools have allowed you to do. An example, I work a fair bit on electronics at home, and I use a soldering iron as opposed to a hot air gun. And because I use a soldering iron, because I'm not very good with one, I burn myself enough that I always put the soldering tasks for anything I'm doing off to the very end of the process. If I had a hot air gun, I would be able to do everything much quicker, much more easily. Wouldn't procrastinate on it, everything would get done, and it would probably be more efficient. Another example is something as simple as the transition from hammer on construction site to nail gun on construction site. It didn't meaningfully transform the way that we did the work, but it did allow for an increase in productivity and a change to the speed at which we could do the work. I would contend that transitioning from CAD to BIM is really no different. It's going to allow us to make new workflows that we don't yet fully understand that are going to speed things, enhance productivity, and avoid rework. To look at a very quick case study of how BIM can be used to fix these, or rather two case studies that my company has been involved in, both bridges, so I believe both relevant examples. The Tamna Bridge was a replacement for an existing bridge across a very deep and somewhat geotechnically challenging gorge in Switzerland. The design that was chosen was one of about 18 that were submitted. And the only reason it was chosen, it was the cheapest design to build, but no one initially believed that it was going to be constructible. So in order to prove that this design, which is very slim and very reliant on post-tensioning and very dense reinforcement configurations, could actually be built on site, the engineering designer wound up building a complete 3D model of the rebar as well as the PT configurations and working with the contractor until they reached a configuration that was constructible. Had this design not been chosen, the next one was nearly double or was estimated to cost about double what the bridge was ultimately built for. So the idea is that through collaboration in BIM and through this early stage visualization, early stage construction analysis, you are able to understand better your design alternatives. You are able to kind of shorten the design cycle enough that it allows you more options. Right now we're getting better at it, but for many years we didn't visualize things early on in the game because it was very expensive in time and investment to do so. To some extent today it still is, but it has gotten, with new tools, it's gotten a lot cheaper, it's gotten a lot easier, and therefore it makes sense to do it much more frequently, especially for projects like this one where they are very clearly going to be challenging conceptually. Another example is the Queensferry Crossing bridge. The initial design was actually for bridge piers that were significantly heavier, wider, and more heavily reinforced than these are, to the tune of costing about double the construction cost of the bridge piers that were designed. But because the entire bridge was modeled, because the entire bridge was modeled in 3D from the beginning, and they integrated the BIM modeling into the FEM quite well, they were able to try a couple of design concepts in the FEM that allowed them to then slim down the design of the bridge pylon. So they wound up bringing this bridge in under budget by about 200 million pounds. It is, at least in my experience and my awareness, almost unheard of for a project of this size and this scope to not only come in on budget, but under budget by close to 15%. So what we've seen with the consultants we've worked with, what we've seen from our product people who have been involved in these projects, is that at the end of the day, BIM's strength, and I'm sorry this font is obscenely small, I don't know when that happened, but BIM's strengths are essentially communication, visualization, standardization, the ability to organize and be more transparent and accessible internally. These pretty much feed in directly to kind of, excuse me, lost my train of thought there, but these feed in directly to kind of shoring up the places that are weakest about our current project delivery workflows. It allows us to better see what we're doing early on in the process. It makes it so that we can more quickly and more efficiently and critically evaluate multiple design concepts early on. It means that interdisciplinary coordination issues are, if not solved, at least made solvable, because we have the tools to tackle them. It allows for better cost estimation. But all of this hinges on getting it right. It isn't just to say that the technology is a silver bullet. You don't need to worry about engineering practice. You don't need to worry about workflows. No. At the end of the day, BIM is a very different workflow and requires a very different approach to CAD. So I will discuss briefly some of the common objections we've seen from consultants and some of the actual challenges. One of the objections that we see most frequently is in terms of skill and retraining. But what we've also seen actually is that this doesn't wind up being a huge challenge when it comes right down to it, that most softwares, ours included, are using fundamentally similar skill sets that already exist within these firms. There is certainly a learning curve. There is certainly training required. It's not to say that you don't need to change anything. It's to say that our people are a lot more capable and flexible than we tend to think going into these things. Another one is communication and coordination. A lot of people believe that this is at heart a personnel issue, that you solve it by changing the way that your people think. And there is some truth in that, but going back to that discussion of culture, the reason that we don't coordinate across disciplines very well right now is because for a long time it was very difficult to do with the tools that we had. 2D plan sheets that are being built or being created by roadway engineers and drafters on one side, and a separate set of drafters and bridge engineers on the other side, with very little overlap in the skill sets and the people between the two, is not a recipe that lends itself to success, because the tools don't lend itself to success. In a BIM environment, when you can have a little bit more coordination, when everyone can see what the other teams are getting up to almost in real time, it becomes a lot more possible to do this. Yes, you need to encourage your people to do it, absolutely, but you can encourage them because they're willing to listen, because they think it's doable and it's easier. The third challenge that people really come up with or fear when we get into this process at first on the consultant side is hardware requirement. our computers aren't good enough for this, our servers aren't good enough for this, our IT isn't good enough for this, we're not ready for this. The reality is at this point that most softwares, ours included, Bentley's included, Autodesk included, these things run on ordinary computers. We're not talking about expensive graphics cards for the vast majority of people. We're not talking about new server installations. But to come along with this, then there are some actual challenges that we see that people don't usually anticipate, that we didn't anticipate when we first got into these transitions with our consultant partners. The biggest one is the idea that right now we're still going to be working in a hybrid workflow. There is always going to be an element of 2D. Some of it comes from 3D, okay? Some of it comes from 3D, some of it has to be built independently. It is very challenging to know going into any given project exactly which is going to be which. To what extent are we doing modeling? To what extent are we doing drafting? What needs to be modeled versus what needs to be in CAD? And then the really fuzzy distinction of what should we model versus what should we do in CAD. Most companies come into this with a pre-existing database, for lack of a better term, of experience and CAD tools and standard details. And the tendency is always to use those as heavily as possible, even though in the long run it might not make sense to do so. It might make sense to start doing some of these things in 3D and building up that same library of details in 3D. 3D for collaboration is a challenge. It's not enough to just have the models and have the software. It's how do you use it? How does it change your workflow? And I wish I had better thoughts to give on it, but I don't think anyone yet understands this incredibly well. How can we use these tools, which open up so many possibilities, to make our jobs easier and to make communication between disciplines easier? I don't have any answers, though I suspect Jamie probably has some thoughts on the matter at this point. And finally, the level of intelligence involved. And I mean this in two ways. One is to say that the software is still not as smart as it ultimately will be and ultimately needs to be, but also that the conception on a lot of people's part is that it is smart enough. We've gotten questions of, when I change my bridge, why can't rebar be parametrically changed along with it? And at the end of the day, the answer is there are an infinite number of ways that you could change that rebar configuration that would work, and an even larger infinite number of ways that won't. And the software is just not smart enough to distinguish between what will and won't work. So there are definitely some mistaken impressions in terms of how much automation can we build into this and still have it work versus what is still going to require engineering judgment. The other note that I would make is that a lot of people, especially, no offense meant, but people who have been in the industry for much longer, seem to fear the degree of intelligence that does exist in the software, that it poses a threat to the way they work or even their job in some instances. At the end of the day, I've worked with companies that had dedicated CAD staffs and companies that have merged that role into the engineering, into their engineers' job descriptions. It doesn't matter a whole heck of a lot whether you're in CAD or in BIM. And it doesn't matter a whole heck of a lot whether your company does or doesn't have dedicated CAD staff. The transition from CAD to BIM is going to involve everyone and every scrap of expertise that exists at the company. Ultimately, you might be able to do more work with the same number of people. Your work will become less challenging. People will be able to go home with sane hours even when project deadlines are looming, but we're not replacing people anytime soon. And there's no need to fear that. So that brings me to the conclusion of mine. Try to get us back on schedule.
Yes, you did. We actually have 2 minutes. He's under. Does anybody have any quick questions they'd like to ask? Either from him or Sandra or Jamie. Is this window? Everybody's numb right now. Okay.
I've got a quick question.
There.
Yeah.
Have you seen in your experience, like what I would call external factors of BIM presenting from being used? One of the things that's come up at Minnesota DOT is they don't like the way that BIM maybe doesn't have a plan of signature the same way that you can have a wet sign, 11 by 17 sheet. And so there are a lot of people that are hung up on implementing BIM just on account of responsibility of signatures. I mean, nothing to do with the technology, just like, well, how do we make sure the document is true? Do you see any things like that that sort of couple up the works and putting it into practice?
Yeah, I would say so. I hadn't heard of that specific one until now. It's not something that we've encountered. One thing that we have encountered is that people are very concerned about what form a QA/QC process takes with a model, for instance. And I don't think anyone has great answers to that question yet. It's very much a matter of developing a set of best practices around this. Another has been the degree to which some DOTs and some companies are very wedded to the appearance of their CAD drawings. And at the end of the day, while that's necessary when you're working in a CAD environment, BIM requires a different type of standardization. It's not necessarily the appearance of the drawings that come out, but the way information is represented within the model, the amount of information that's represented within the model. And I don't think anyone's quite there yet.
Just a quick comment on that. A few states have resolved that. For instance, in Iowa, a couple of meetings with the licensing board, and they worked those details out. So Iowa, Utah, let's see, which other states? Connor, Jamie?
Michigan is part of it.
Yeah. But, so especially Iowa and Utah, it's all sorted out, and I'm sure they'd be happy to share with you how they're working. Yeah, that's not the first time I've heard that. That's certainly been a question, but there are answers.
It's kind of a mindset too, it's cultural. Danny Kaler said it best, you're trying to fit analog processes with a digital tool. You can't. We don't conduct lessons anymore on how to load film in a camera anymore. It's a digital world. So film is irrelevant, and in BIM, producing sheets is not the end goal of it, so it's just a different mindset.
Yeah.
So,
there's going to be a long transition period where we're doing both, and we're going to have to develop some best practices for accommodating both in parallel.
mm-hmm.
But at the end of the day, we don't want to invest a ton of time and a ton of effort developing best practices for a workflow that is transitional in nature.
Yeah, very good. Let's thank David. That was an excellent